Hello, so welcome to chapter 6. The previous chapter, tumabanga covers sets, and in chapter 6, we'll be covering mapping and functions. So, I am your presenter, Aram Nyondo. So, what are relations? A relation is a rule that defines a connection of one set to another. So I have underlined the word rule and the set. Now, rule, panthawi tinkaphunzira number sequence tikanena kuti mwachisanzo ngati ndi number sequence 2, 4, 6, 8. For example, if you have this sequence and we say what is the rule that this sequence is following, kapena kuti sequence iyi ikusatira lamulo loti chani, how are we able to find the next term? So abapa timanena kuti so we are adding 2. So tikapanga add 2 ku 2 we get 4, 4 2 6, 6 2 8, and using that rule we can be able to find other terms in the sequence. So many timagwisa ntchito mauti rule ku number sequence tumene, so we should be able to apply timakakamba za mapping and function. So we're saying a relation is a rule that defines a connection of one set to another. So there are two sets. So we're trying to find kuti pakati pa 2 sets amene wawa palubale wanji. Mwachisanzo set A ndi set B akugwirizana motani kapena palubale otani. Again, there is another definition which is it is a connection between mathematical concepts. So this is a more mathematical definition. Imene kwambiri kuyang'ana kuti kodi pa 2 concepts palubale olanji kaumana, where is the connection between these 2 mathematical concepts. So these 2 definitions are what are relations in mathematics. Now, let's move forward. What are examples of relations? So when you use the word relation, it can also apply to human relations. As humans, we have relations. We can also be a relation between things. It can also be a relation in the diagram. So relations can also be represented in diagrammatical forms. So relations can also be represented in diagrams. And also we are going to look at other relations in mathematics. So let's start with human relations. What are examples of human relations? Now, for example, let's look at an example of a human relation. Ben is a brother to. So Ben is a brother to Daliso. And James is the father to Chisomo. All right. How are Ben and Daliso related? Pakati pa Ben and Daliso palubale wanji. They are brothers. So pakati pa Ben and Daliso palubale wanji, they are brothers. So it means this word, a brother to, ndimene yukuruza relation. Ubale wa Ben and Daliso. James is the father to Chisomo, the father to. What is the relationship? What is how are James and Chisomo related? So they are related as in James is the father to Chisomo. There can be other examples. Let's look at the relationships between things. Example, Nzimba is larger. Nzimba district is larger than Mwanza district. So what is the relation there? Is larger than. So we're trying to establish ubale pakati pa Nzimba district ndi Mwanza district. How are they related? Zimba district is larger than Mwanza district. Another example, a 1-ton lorry is smaller than. So this word smaller than ndimene kutuza ubale pakati pa a 1-ton lorry and a 7-ton lorry. Now, we're saying relations can also be represented in diagrams. For example, we're discussing sets in our previous lesson. So, for example, we have got a set A whose elements muli 10, 20, and 30, and a set B whose elements muli 20, 40, and 60. Now, we have got these two different sets. Now, we're trying to establish kodi pakati pa set A and set B palumbali wanji. Now, how are we showing the relation? How are we showing the connection between set A and set B? Remember, our definition is it is a rule that defines a connection between two sets, or one set to another. So, how are these? What is the rule? What is the rule connecting set A and set B? So we're saying this arrow is the one representing the rule. So the arrow is the rule there. So what does this arrow mean? So this arrow means times 2 is equal to, like that. So if we say 10 and the arrow say times 2 is equal to 20. 20 times 2 is equal to 40. 30 times 2 is equal to 60. Like that. So the arrows are the ones that are showing us the relation. So this is relations in diagrams. Let's look at another example. Other relations in mathematics. For example, 2 is a factor of 12. So remember what are factors? So we're saying 2 is a factor of 12, which is true. So is a factor of So 2 is a factor of 12. So is a factor of 12. This one is showing how 2 is related to 12. 6 is a square root of 36. So square root of shows us how 6 and 36 are related. Another example, 4 is a HCF, highest common factor, of 16 and 20. That's very true. And we're trying to show how 16 and 20 are related. So how are they related? They have got a common factor, a highest common factor. Other relations can go up to looking at the relationship between triangles. We learned that in the topic when we are discussing similarity in Form 2, for example, we say triangle ABC is similar to triangle XYZ. So how are they related? They are similar too. So this is the rule, this is the rule, this is the rule, and this is the rule. So these are examples Yama relations in mathematics. So finally, let's also look at the one last example of relations in mathematics. A good example is when we are putting values, table values of a certain graph. For example, in our case, we have got the graph y is equal to x plus 1, and this is the table values. So when x is -1, y is 0. When x is 0, y is 1. When x is 1, when x is 1, y is 2. So we're saying for every x value, we have a corresponding y value. For every x value, we have got corresponding y value. So as you can see, if, for example, we have got, say, when x is 2, if x is 2 there, how are we going to find y? So if we input this into our equation, what are we going to find? If we put 2 there, so 2 plus 1, y becomes what? Y becomes 3. So whatever x, whatever the form of x is there, whatever x coordinate is there, there is a corresponding y value if we use this equation. So when you see the topic mapping and functions, we have been learning it in different topics. So it has been covered matopic osiyana-siyana, number sequence, sets, and now in linear graphs and linear equations. Let's move on. Now, one other term that we're going to find as we're discussing mapping and functions is the word mapping itself. What is mapping? So, let's look at an example. We had this table of values. Now, if we take this table of values and express it ngati an arrow diagram, how is it going to look like? So we are using express a table of values, this one, this table of values, and as an arrow diagram. So this is our x and this is our y. Now this is our x values, this is our y values. Now using the arrow diagram, so we have got x in one set, we can say one set, and we've got y in one set, and we're using the arrows. Remember, what does the arrows mean? The arrow is the rule. So in our case here, this is the rule. This is how x, y becomes. This is, in order for us to find y, we need to put the values of x into this equation. So following this rule, following this equation, the values of y, so -1 is related to 0, 0 is related to 1, 1 in x is related to 2 in y, like that. And we can continue if there are other values, if there are other elements in this set here xe, we can relate them to the other corresponding elements in y. So following this rule, we can be able to also find the other elements that are found in y by following this rule represented by the arrows. So -1 is related to 0. 0 is related to y. 1 is related to 2. So remember, these are in the x set and these are in the y set. So how else can we say that the values in the x set are related to the values or the elements in the y set? Mapping continued. So 1 is mapped onto 0. So instead of saying 1 is related to 0, we say 1 is mapped onto 0. Instead of saying 0 is related to 1, we say 0 is mapped onto 1. Instead of saying 1 is related to 2, we say 1 is mapped onto 2. So this is mapping. When we are trying to establish, when you are trying to say the relationship between elements in one set, how are they connected to another set? That's what we call mapping, demonstrating the relationship. So back to this example. So we can say this arrow is also saying -1 is mapped onto 0. So the arrow now is saying that 0 is mapped onto 1. 1 is mapped onto 2, like that. So this is what we call mapping. Another term that we will come across as we are learning mapping and functions is an ordered pair of numbers. What does this mean? An ordered pair of numbers is a pair of numbers of, so when the numbers are expressed this way, numbers yo agayikidwa mu njira yotere, it means that's an ordered pair of numbers. Chidule, that's what we are trying to say. So tuona kuti ifeyo sikoyamba kupanga express ma numbers this way. We have been doing that since coordinates, topical coordinates in the form 1, where we're trying to find a point on a graph. So we used the x values and the y values, the y coordinates and the x coordinates and the y coordinates to locate a point. So we have been using these, or we have been applying another pair of numbers to express points on a graph. So it's not new. The only new thing is this term we made ntchito. We know this. We know x, y, that it is used to express to show a point on a graph. So an example, we're saying we are writing -1, 0, where now -1 is x, where y is 0. So y -1 is an x coordinate and 0 is a y coordinate. So this is not strange to us. Alright, finally, let's look at some other terms that we'll come across as we are discussing mapping and functions. Domain, range, and function. So the topic is mapping and functions. We have explained what mapping is, and now we are finishing by looking at the term function. So we're saying a domain is a set of x coordinates. Let's stop there. A set of x coordinates. Now, where again do we learn about x coordinates? Remember, in a linear graph, this line imenimanyamula ma x coordinates, the x axis. This is the reference. This is the line that is being referred mu definition yatu. They are discussing about this line timagamba za linear graph. So this line, tikapita so ku physics, tikapita ku chemistry, what other name did we use for this line or for the values amene timayika on this line. So if you remember, we had terms like independent, komanso tinali ndi input variables. So we had these terms which were used to which were applied to express ma values amene angapezeke pa x-axis. Why were they put there, or why was this line called imene imachedwa kuti ikhala ya independent variable mu experiment yathu? Right? So nkhani inalendo kuti in variables we have input variables and output variables. Input variables amapanga affect ma output variables. A change in input results into a change in output. So we call these ones independent variables or input variables chifukwa iwowa ndi amene amapanga affect the values amene angabwere pa y. Tikapita ku ma coordinates muja kuti upeze ma y, tikapatsidwa equation. For example, we're discussing an equation like this. Kuti upeze y, it means umakhala kuti wapeza kale ma x variables or elements in x. So finding the elements in x, ukadziwa ma element amenewa ndi amene umagwiritsa ntchito kupezera y. Now, the definition is also saying, or it is a set of all acceptable input values, input variables in a relation, all acceptable input. Now, we said range or codomain is a set of y coordinates. Now, going back to our graph, this is the y coordinates. So all the values amene amapezeka pa y axis, those are the y coordinates. So these y coordinates, we're saying they are the range. Or what are we saying? We're saying it is a set of all possible output variables. Output variables. Akucheda ma output chifukwa chani? Chifukwa chakuti kuti abwere. Remember, we said y is equal to x plus 1. And in order to find y, timasintha the value of x. So tikayika x apa, x yo ndamene akutipatsa y. Tikasintha x winanso atipatsa y wake, x winanso atipatsa y wake. So y ndamene akutuluka, output ndamene akutuluka mu equation yathu. Akutuluka after talowetsa x. So that's why these ones are called input variables, input values, and these ones are called output values. So in the relation in our rule. So following this rule, we have got x as input, then the output is y. So in order to find y, suma lowetsa y here, umalowetsa x. Ukalowetsa x, umapeza y wake. Each and every x value has a corresponding y value. So this is the difference between a domain and a range. Chidule imamba the domain, then we find the range. The domain are the input values, while the range or the codomain are the output values of the relation. Finally, let's look at a function. Now, what is a function? So a function is a special type of a relation. So a function is a relation, a special type of relation. What's so special about a function? So a function is a relation where each element in the domain has exactly one corresponding element in the range. What does that mean? Simply, timanena kuti if we have x and y there, and from our example, we had the -1 there, 0 and 1, and about napeza, if we input, so our equation was y is equal to x plus 1, and tikatenga a -1 kuika apa amatipasa here 0, tikatenga 0 kuika apa amatipatsa 1, tikatenga 1 kuika apa amatipatsa 2. So from here again, remember, ndekuti mene palili apa, this is our domain and this is our range. So if this one is to be called a function, akunena kuti where each element in the domain, this is an element. Remember, the domain, to use about element because they are also sets. So we're saying each element in the set is exactly mapped, is exactly related to one element in the range. So where each element in the domain has exactly one corresponding element in the range. So if we map them like this, as we have been doing with the examples, so we're saying now this is a relation, but what type of a relation? It is a function. So basically, we are saying a function, it is a type of relation, meaning there are other types of relation, and those ones we're also going to cover later as we discuss mapping and functions. That's all for today. I hope we have taken something. If you have any questions, please leave it in the comment section. Thank you.